In this lesson, we're going to learn how to analyze indicators of malicious activity. Let's get into it. As security professionals, we can't just rely on automated tools to spot threats. Let's break down how to recognize different types of malware and understand their behavior so we can detect and stop them effectively. Automated detection systems are powerful, but these malwares are like Pokemon. You can't catch them all. Knowing the signs of malware infections help you respond quickly and keep your organization safe. Malware is any software that does something harmful to a system owner. Some malware types are sneaky and tolerated by users without them realizing it's risky. We could classify malware by attack vectors, how they spread. You have virus and worms. These spread without user consent by hiding inside other executable files. For example, an infected USB drive is plugged into a computer, and the autorun feature executes a hidden worm that spreads across the network without the user realizing it. Then you have your Trojans. These are malware hidden inside software that look legitimate. They install without consent and work secretly in the background. And then you have your potential unwanted programs, your PUPs, or applications, your PUAs. These are installed alongside other programs or pre-installed on devices. They're not always malicious, but often they're annoying or privacy invasive. They're also called grayware or bloatware. Now let's classify malware based on what it does. You have spyware. They monitor user activities. You have rootkits. These hide malicious actions. And then your remote access Trojans, your rats. They give attackers control over systems. And then you have your ransomware. These lock files and demand payment. A virus replicates itself by infecting executable files or code. Different types of viruses are non-resident file infector. They infect files and run with them. Memory residents. These load into memory and stay even if the host program stops. Then you have your boot virus. They target disk boot sectors to run when the system starts. Then you have your script and macro viruses. They use scripting engines like PowerShells, VBA in Office, or JavaScript and PDF to execute. Some viruses are multi-partite, meaning they use multiple vectors, or polymorphic, meaning they change their code to avoid detection. Viruses need a host file or media to spread, and they travel via email attachments, download, USB drives, or network shares. Now let's talk about worms and fileless malware. Unlike viruses, worms don't need user actions to spread. They exploit vulnerabilities to replicate across networks. Here's an example. The Code Red worm, it exploited Microsoft IIS server. They spread rapidly and caused denial of service by consuming bandwidth. And then you have your fileless malware. These are modern malware that are becoming smarter. Fileless malware doesn't write files to disk, making it harder to detect. Instead, they run directly in memory, often using legitimate tools like PowerShells or WMI. It uses shellcode to create backdoors and download more malicious payload. Shellcode, by the way, is a small custom code used by attackers to run commands on a target system. And the fileless malware, it often changes the registry to maintain persistence after it reboots. This approach is called living off the land, where attackers use existing system or tools to avoid detection. Alright, now let's talk about spyware and keyloggers. Early viruses and worms were all about spreading and causing damage. Today, malware often have another goal, making money through intrusion and data theft. Let's look at how spyware and keyloggers fit into this. You have tracking cookies and super cookies. Now, cookies themselves aren't malware, but tracking cookies, they record what sites you visit, your IP address, and the browser details. They're created by ads and analytics on websites. And then you have your super cookies. They take tracking further by adding extra chocolate chips. I'm just kidding, checking to see if you're paying attention. Super cookies store data in hidden ways, like browser cache or headers, making them harder to delete. And then you have your beacons. These are tiny invisible images on websites. When your browser loads them, it sends information back to the server, revealing your browser habits. Alright, and then you have your adware. Adware is software that changes your browser settings. They add bookmarks or open sponsored pages. They allow more tracking cookies. and they come as a program or browser extension. And then you have your spyware and keyloggers. Spyware take it further by monitoring apps you use, taking screenshots or activating your webcam or your microphone, or they redirect your DNS to fake sites, farming. Keyloggers record every keystroke. They're aiming to steal passwords or credit card numbers. Pretty scary. They can be software-based, like script capturing keystrokes and sending them to attackers. Or they can be hardware-based, like tiny devices inserted between your keyboard and your computer. Alright, let's talk about backdoors and rats. Backdoors let attackers bypass normal logins to gain access. Remote access Trojans are malware versions of this. They act like legitimate remote control tools but operate secretly. Once a rat infects a host, it can upload files, install malware, or create bots. These are remote devices that are not aware that they're being controlled. Multiple bots can form a botnet. They're used for DDoS attack, spamming, or crypto mining. And then you have your command and control connections. Rats need a way to communicate back to their controllers, the C2 servers. They often hide these in HTTPS or DNS traffics. And there are other backdoor sources. Not all backdoors come from malware. Sometimes developers leave testing backdoors in apps. And sometimes it's misconfigurations that allow for unintended access. Alright, let's dive into rootkits. A rootkit is a malware with a system-level privilege, meaning it can control everything. If a user installs malware with admin rights, it can change the system settings. Some malware exploit vulnerabilities to gain system access without user approvals. Rootkits can hide from task managers or antivirus tools. They can clean logs to cover their tracks, or they can live inside the firmware, which means when you install the OS, they're still there. Alright, that's enough on malware. Here's a recap. We learned malware classification include virus, worms, Trojan, PUPs, spyware, rootkits, rats, and ransomware. We learned viruses need a host file to spread, while worms spread without user action. We learned fileless malware run in memory, using tools like PowerShell to avoid detection. We learned about spyware and keyloggers, and how they steal data by monitoring user activities and keystrokes. We learned about backdoors and rats, and how they provide secret remote access, often creating bots for botnets. And lastly, we learned how rootkits give you system-level privileges, hiding their presence and surviving reinstalls. See you in the next one.